Okay, now we're still in the section on series, but we're just going to deal a little bit more on the rules of sigma notation. Rule number 1. For any given two sequences A and B, the sum of A and B is the same as the sum of A plus the sum of B. This is quite an easy to understand one. Rule number 2. For any constant C that is not dependent on the index I, as you can see there's no I next to C, then we can say the sum of that constant times the sequence is the same as that constant times each term in the sequence, which is the same as that constant times the sum of each term in that sequence, which in sigma notation is the same as taking that C out and saying it's the constant times the sigma of that sequence. Rule number 3, also known as the bracket rule. It's not so much a rule as a heads up. Let's just take it by example. If we say, what is the sigma of 3x minus 1? Now notice here I've changed this to x. This is just to keep you realizing that we can change it. It does not have to be n, does not have to be I. But what it's saying here is x increases from 1 to 3 in unit steps of 1. So when x is 1, that will equal 2. That's 3 times 1 minus 1, which is 2. When x is equal to 2, it's 3 times 2, which is 6, minus 1 is equal to 5. And lastly, when x is equal to 3, it is 3 times 3, which is 9, minus 1 is equal to 8. So we can sum that up to get our answer of 15. But now be careful. What if we had the very similar looking sigma notation, but with the brackets at a different place? How would this work? Here we can see we said from x is 1 to 3, 3x, and all of this in the sigma, so we must do it all by itself, minus 1. So for example, 3x times 1 is 3, 3x times 2 is 6, 3x, or x is 3, is 9, and then afterwards we minus 1. So we can add that up and get 17, which is completely different. Now lastly, again not another rule, I just want to tell you more about sigma notation. For any value, for the values of I, it will start at m, it doesn't always have to be 1, and that's down at the bottom here. For the values of I, it will increase in steps of 1. It always increases in steps of 1. And lastly, it will always end at n, and that's the value on the top. Great, well done.